right. This is CS50, and just 8 weeks ago, 2/3 of you had never studied any computer science before. And what we thought we'd begin with today is really a look back of truly how far you've come over just those several weeks. In fact, it was just 8 weeks ago when you first started tinkering with Scratch, this graphical programming language via which you could drag and drop puzzle pieces and make the computer do what you want. And then a week later, you might have struggled with just getting Mario to ascend a pyramid by way of hashes that you were printing with at the time. Was perhaps quite non-obvious, but it's ever since has just been what? A pair of nested for loops. And then the week after that, you explored cryptography among other fields, and you learned how to encrypt, and you decrypted information like this snippet here. After that, you explored some electoral processes and the implementation of algorithms that you might be familiar with from the real world, but perhaps didn't think about the trade-offs in choosing one algorithm or another and then ultimately implementing it in code. Just a week later, did we transition to filters a la Instagram, implementing things like your own sepia filter, so that moving forward, hopefully you won't take for granted when you click that button on the screen on your phone, you actually know or can presume or infer what's going on underneath the hood as it changes from one setting to another. And then, of course, Big Board, where we handed you some 140,000 English words in a really large file, and you had to implement your own spell checker, a dictionary, so to speak, with using as little amount of time and as little space as you could, implementing ultimately your own hash table. Thankfully, since then, we can now take for granted that those things exist, but you indeed built that from scratch. Just a week later, we started handing you large files like this, and of all things, you were able to deduce by writing some Python code that this is Lavender's DNA, among others in the class whose files we handed you. And then most recently, or perhaps quite soon, will you learn to apply another language, in this case SQL, to questions like who has starred in films with Kevin Bacon. And so a number of tools are now in your toolkit. And again, I would just emphasize that 8 weeks ago, 2/3 of you had never done any of that before. So even if it's felt like it has never let up and each week feels all the more challenging than the last, consider the delta and consider what we promised in the first week of the class, that what ultimately matters in this course is not so much where you up relative to your classmates, but where you end up relative to yourself when you began. And it is indeed those 8 weeks ago that you began, and it's today and in the course's final weeks that you will ultimately be able to compare yourself. So in trying to think today about what we hope your own takeaways are from not only the course, but computer science more generally, I actually pulled up some of my own notes. You might recall from week 0 that I mentioned I took this course myself back in 1996, and it happened to be the one that turned me from a government major to a computer science major. And I didn't take many notes at first, it seems, in that first class, though there were a couple of other pages. And so I started flipping through these. And in fact, this was my second page of notes. And if you focus on what's up here at the top, apparently one of my first notes to myself that a function, for those unfamiliar today, are instructions that do the work. And indeed, if I looked down further on my notes, arguments, we introduced that same first day. It's info that's passed from one function to another to have something done by or performed on it. All right, so that actually maps wonderfully cleanly to what it is we indeed started ourselves doing those 8 weeks ago, just talking about what CS is, problem solving. And a problem is just something that's got input, and the goal, of course, is to produce something with output. And we had to agree from that very first week how we're going to represent these inputs and outputs. And so we might do it symbolically with letters of the alphabet. We know since then that we might do it numerically, as with decimal digits. Or below that, we might just use binary, a different base system, using only zeros and ones. Or we could even represent that same capital A just using some pattern of light bulbs or switches that you turn on in some order. In fact, if you think back then to these first principles that we introduced those weeks ago, to any of the students now in the audience, what does this say? Hi. So it indeed says hi. Why is that? Well, we just agreed weeks ago on what numbers map to what letters. And so long as all of the humans in the world agree on that, whether sending emails or text messages or the like, our computer systems can all present information that we ultimately understand. Another review question from week 0. What did this say way back when? If you need a hint, it was in decimal 128,514. A little louder? Emoji. This was the face with tears of joy, right? Taking all of the fun out of sending emojis. Anytime you receive or send an emoji, really all you're sending is a pattern of zeros and ones, or worse, the number 128,514. But your computer or phone are presenting it to you in a certain way based on that context, all based on just how we humans or those before us decided how to represent this information. But of course, we don't have just those inputs and outputs. There's another piece to the puzzle. And so I actually look back at my own third page of notes notes here and focused on my first line here back in 1996. An algorithm is apparently a precise sequence of steps for getting something done. And programming more generally is a process of taking an algorithm and putting it into a language a computer can process. And indeed, that really was the additional puzzle piece we first focused on in week 0. It was what was inside the proverbial black box, the sort of secret sauce that you provide your input to, you get your output from. Those are the algorithms that we've been talking about ever since now, not just in pseudocode or in English, but in C and in Python and now SQL, and then in the coming weeks, a few other languages as well. But of course, we used algorithms to solve problems, and one problem is and was rather old school, and we thought we'd reflect just a bit and perhaps reinforce that same week 0 by taking a couple of volunteers, perhaps a student and one of their family members, voluntarily or forcibly with them. You have to be comfortable, though, appearing on stage and in turn the internet in perpetuity is the catch. I see one volunteer and either mom or dad fighting out who's not going to go up. OK, come on up. A round of applause if we could for our volunteers. Come on over this way. And what is your name? Daniela, nice to meet you. Come on over here. And what is your name? Mariano, and your dad, I presume.
Yes.
All right. Well, so nice to see you both. You'll recall from week 0 that one of the first problems we solved was looking up someone in a phone book. Well, here I have a pretty thick yellow pages wherein there's a whole bunch of products and services alphabetized from A to Z. And we can, of course, look up the number for someone in this book. For instance, suppose today we need a plumber. Could we ask Mariano to find us a plumber in this phone book? Flipping through a few pages, a lot of pages. Okay. Yeah, OK. All right. And we have a page full of plumbers. And now, could your dad have done better, do you think? Yes. Could you? I think so. So would you like to show dad and other parents here what you might have done instead? Oh, my goodness. OK. Thank you. And for those wondering, let's continue the algorithm, if you will. What's your next step? Nice. And why are you doing this, though?
So I open halfway, and then if it's not on the page and it looks like, for example, if it's N, I know P is afterwards, so I need to get rid of the first half and just look at the second.
Well, need to is a little strong, but you can get rid of. Yes, indeed. So if you keep this process going, having and having and having, what should you be left with ultimately?
Just the letter P.
Just the letter P. So a round of applause if we could for both of our volunteers here. Thank you. A CS50 stretch ball for you both. Thank you so much. Oh, thank you. Thanks. So that was one of the first lessons with which we began focusing on algorithms. And the point back then, recall, was to really emphasize the familiar, right? We might not use that particular technology all that much anymore, but it really is fundamentally the same thing that's now in our iPhones and Android devices and the like. It just so happens that we search for things by scrolling with our finger up and down. But consider, too, even these days in 2019, when you type into the autocomplete to search for someone by first name or last name, how is your phone finding that information? It's exactly like that. Not quite as physically as that, but most likely for efficiency, your phone is looking roughly in the middle of all of those names, then jumping up or down in the blink of an eye in order to find that person for you ever so quickly. And so all of us might have an intuitive understanding, it just like Mariano did for finding plumbers by jumping to the P section, but then you came close to the P section, but then started flipping. And I dare say you flipped through far more pages than you ultimately needed to, using our more efficient divide and conquer if one time only algorithm instead. So beyond algorithms, I recall that I had just a few other notes. On my last page of notes, I also had this here, that what was apparently important then, and no less so now, is that in computer science and in turn programming, precision is important and correctness is important. And indeed, one of the things you perhaps gleaned in programming, whether in Scratch or C or Python or SQL over the past few weeks, is that the computers are really unforgiving, right? They can't just infer like we humans do. And frankly, I'm not sure we would want our computers to just infer sometimes what we mean if the goal is precision and correctness. You need to be ever so precise. So let's see, perhaps, with one more demonstration, just how much this one has perhaps sunk in. If we could get perhaps two more volunteers, a student and family member as well. Student and family member here, and I don't see a family member's hand up. Can you convince one? OK, come on up. Wonderful. A round of applause for our other pair of volunteers here. So now for this one, not everyone's off the hook. If all of the students in the room, if they have a piece of paper and or pen or pencil, could take that out and share with anyone next to you if you don't have. Emma and Brian are also going to pass out some paper and pens if you don't have a writing apparatus. The goal at hand is actually for all of us to participate, thanks to our 2 volunteers. And what's your name?
David.
David, nice to see you. Yuchimpa.
Yeah.
Nice to see you as well. Come on over in here. And this will be a 2-part exercise as well. And the first goal at hand is for you to choose. Do you want to go first? Or Dad, is it? Would you like your dad to go first?
Okay, I'll go first.
You're going to go first. All right, so come on over here. And what I'm going to show David in just a moment is an image on the screen that I'm going to ask that he program you, the audience, to draw, giving verbal instructions only, the goal of which is for him to be as precise as possible and as correct as possible to compel the audience, much like a computer, to follow his instructions and in turn implement your algorithm. So in just a moment, David is going to rattle off step-by-step instructions for having everyone in the audience draw this. You are the only one that can see what's on the screen. Everyone in the audience, just about, has a piece of paper and a pen or pencil. And I just need you, very confidently, clearly, to recite step-by-step instructions by which everyone with their pen or pencil can draw what you see on the screen here. Make sense?
Yes.
You may use any verbal instructions you like.
Okay.
All right? Just about ready to begin? And the goal, precision, correctness, begin.
Okay. Step 1, draw a sideways square. Sideways, 45 degrees rotated. Yeah.
OK.
From the bottom 3 corners, draw a straight line down. That's approximately the length of each side of the square.
Unfortunately, programs cannot ask questions of programmer, so we continue on with next step.
And finally, at the between the first and second line, draw a line connecting the 2 at the end. And between the second and third line, draw a line connecting the end.
All right. How do you feel about your instructions? Precise and correct?
Wishy-washy.
Wishy-washy. OK. All right. So let's go ahead. Hang on to the mic for just a moment. I'm going to hop down into the audience with our TFs just to grab a few representative solutions. If you wouldn't mind my grabbing a few sheets of paper from folks who have participated. Let me take a few over here. Just a random sample. You're welcome to volunteer proactively or keep it to yourself. Let me go in over here. OK. Thank you so much. Any takers over here? OK. All right. Good. 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 Whoops. Thank you. And all right, the TFs are grabbing a couple too. Oh, I see some over here. All right. That should do. That should do. Let me grab these from Brian over here and Emma. These are blank. Oh, those are blank. All right. So I think we have plenty over here. So let's take a look before we do part 2 of 2, if I may, at how well David programmed the audience. I'm going to go ahead in just a moment and pull up a projection of some of these drawings here that are the results of these operations. So let me flip through, get a sample here. And I see a lot of good options here. I see this picture here, which perhaps resembles what you drew. See this one here in the top corner, very similar in spirit. This one left a lot of room for other things, but there. This one was a little more abstract, if I may. And so let me go over to a spoiler to show you what it is David was programming you to draw. And with some suspense, he was compelling you to draw, we hope, this here. All right. So close or not close, perhaps. All right. A round of applause for David, if we could. Thank you. One more. And so you used, if you would, abstractions, right, in discussing this. You said a sideways square, used 45-degree angles, hoping that folks would presumably know what you mean by that. Why did you not just say draw a cube, for instance?
I felt like that would be cheating.
OK. Well, it would not have been cheating, but it would have been a wonderful abstraction, right? If everyone in the room, assuming, knows what a cube is, you might then be compelled to draw it quite quickly. But that, too, leaves ambiguity and lacks precision. Well, how is the cube oriented? Is it this way? Is it that way? Is it curved this way? So sometimes these abstractions aren't sufficiently helpful. So I probably would have done what you did as well. Now, let's do one other example here, if we could. I'm going to go ahead in just a moment and project an image onto the screen that everyone in the audience can see except you two. Let me go ahead and re-angle this a little bit. And if father and son would like to get together or solo, draw a picture that the audience is going to tell you how to draw. So we're going to flip the roles now. You all will see the drawing on the screen. We ask that you tell our volunteers what to draw. You can use any words that you want, but you cannot ask questions and no physical gestures to explain. All right? Unfortunately, it's a little hard technologically here in that the solution's going to be there, the solution's going to be there. So we're going to have to kind of put some visors on you, if we could, so that you can only see straight forward. And if you don't mind, hugging the board as close as possible, but occasionally back up so that people can see what you're drawing, but resist the temptation to look up, over, left, or right. All right. So for our audience then, the image is, and if you two could focus only on the board now, only on the board and definitely not facing that screen. OK. The audience is about to see the picture in question. And so we need a volunteer first from the audience to call out an instruction. Any step ones? Over here. Make a circle. Oh, I heard a small. I heard draw a smaller circle. I didn't hear use the eraser, but OK. 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 And no looking at me. No looking at me. All right. So I'll take a third step. So let's go to someone else. Yeah. Draw a vertical line from the center of the circle, from the bottom of the circle and down. I hear an abstraction. So we were also given a fourth instruction. Draw a stick figure that appears to be walking, if that helps. But I think we're going to need to be more precise here, because I could imagine a stick figure doing multiple things and multiple. OK, maybe step 5. Do we want to make any tweaks? It's draw an almost upside down triangle, I heard. Through the legs. For the legs.
After the vertical line coming down. You need to erase the legs.
OK, I heard erase the legs. And get rid of the arms. OK, and step 5 was?
Is from the bottom of the vertical line, the body, make the two legs are like a triangle without the bottom part of it.
From the bottom of the body, draw like a triangle to represent the legs. But not that way. That's good. Let's move on to step 6. Step 6. Someone over here?
So once they erase that triangle, from the bottom of the vertical line, draw an upside down V, where the center of the V is touching the bottom of that vertical line.
From the bottom of the straight line, draw an upside down V. I think we did that. Can you step aside just so the audience can see? No, we have a tripod. OK. OK. OK, so I think we're there. I think we're there. One other instruction. Let's see if we can take this home. Yes, right here.
Draw a less than symbol starting from the base of the middle end of the circle.
Draw a less than symbol from the base of the middle of the end of the circle on the left side. Oh.
Wait, a less than symbol.
Less than symbol from, yep.
Less than.
Yes. So this is what we call a condition. So yes. Correct, I hear. OK, I think we're close. 2 more steps maybe?